Hello, and welcome to stream number 71 in this series where I am programming an NES game live on Twitch, although it's been a little while. In the last stream, we had Nathan Tolbert from Bite the Chili, who had made Anguna and Robo Ninja Climb, and working on a new game called Halcyon while I was in Illinois. I was actually in Chicago and drove out to Nathan, and we got to chat about NES programming and his background. I feel like we've kind of bunched up some of these interview streams just because of my schedule, and then I was sick after coming back from Chicago. I think it's the combination of travel, and then I was on, you're on a plane with a bunch of people who were potentially sick, and then on top of it had to go to a wedding immediately upon return. So it's been a pretty busy couple of weeks, and then we had Thanksgiving last week. So today I'm kind of today is the first day I think I'm kind of feeling back to normal. So we're back to programming, and Wednesday of this week we will be streaming again instead of Thursday, and that's why I said I feel like these interview streams are kind of bunching up. I've got someone lined up for Wednesday because Wednesday works better for him, so Wednesday at 9, I'll announce who it is on Wednesday. But let's get into this and get back to some coding here. One of the things that I wanted to do tonight was I wanted to work on the way that we are converting PNGs, because right now we are taking our indexed PNGs and then kind of just mapping them directly to the palettes that or the palette colors that we had defined in here, I believe. Yeah, so we have this NES palette, and I'm pretty sure I based that on I'm pretty sure I based that on the palette from FCEUX. I decided that I would like to be able to take an RGB PNG, and if it's not indexed, convert it to be an indexed image using the NES palette. So one of the things that we need to do is know if our image that we're loading excuse me, and I apologize in advance for coughing or any sort of throat clearing noises. I'm still not 100%, but as I said, much better. But I'm still going to have some of this congestion that I'm working through here tonight. So anyway, so as I was saying, we are going to be dealing with this only if we know that it is a non-indexed PNG. And the way we can know that is I had made a change to this load image call a ways back, where when we loaded the memory and then we loaded the PNG, we had added this indexed variable that we allocate and we configure with the indexed memory. We call this dpalette call. So what I wanted to do is I wanted to change it so that if it's a paletted PNG, what we'll do is we will keep the indexed value as null. So when we come out of this call, we can look at that value, the indexed pointer, and if it has no value in the index, then we can essentially pull that out of sorry. If we see that it's not paletted, we can convert the values over to paletted values based on the NES palette, and then we can deal with, you know, if there are too many colors. But let's start there. So if current image indexed, so if it's null, then we want to convert image to indexed current image. So I'm going to define that somewhere. And the way we're going to do this is we're going to convert the RGB color into YUV and then use the corresponding NES RGB value converted to YUV to see which one is the closest. I think, well, let's start with the call. So convert image to indexed tiger. Just tiger. I don't remember now. Tiger bitmap image. And so maybe we'll type what did I do? Is it going to be one of those kinds of innate? And again, this is like, oh, it's just tiger. I don't know why. It's one of those things where I've been away at the from the code for a while, so I'm going to have to kind of fight my way back into remembering what the hell I'm doing. Also, I got some feedback. I got a chance to meet two people while I was in Chicago. I met with Nathan. Obviously, that was on the stream, and then I got the chance to meet and hang out and talk to this guy Scott Hyatt. He's on Nintendo Age as well, and we got to talking about NES programming, and he showed me a cool project he's working on. But he gave me some feedback that the text is really hard to see. And so I've increased the size. Hopefully that is better and you can read what I'm coding. I usually kind of check out the recording after the fact on my phone, so it didn't really occur to me that it would be too small. It was just kind of like, yeah, it's on my phone. Of course it's too small, but anyway, so just figured I'd try and address that. So the image is width times height is our RGB value for the image, and then so one of the things we probably want to do is we probably want to store off the YUV values here. Let's take a look at this for a second. So this is just a pixel PR, PG, PB, PA. Maybe we can reuse the RGB or the pixel and just well, we've got, do we have a vector 3? We do have well, we have a vector 2, right? We do have a vector 2. Let's do this. So what are these? These are chars. We can create that vector 3. And the reason I want to do that, you'll see in a minute, but all right, so I mean, it's just syntactical. It doesn't really affect anything per se, but I do want to call it XYZ and treat it as a vector 3. In theory, we could do some implementation of matrix math, but I don't really want to do that. That's going to be too much. It's going to take too long for the purposes of what we're trying to do here. So what I do want to do is I want to manually convert, or not manually, I want to write some code to convert the NES YUV palette information into sorry, the RGB palette information into YUV palette information. Let's talk about that for a second. So YUV is a mapping of colors that can be used, and the reason, based on what I'm reading or have read, that we want to use that is, the idea I had was, well, we could take RGB and treat it as a 3-point vector, or a 3-dimensional vector, and so if you get different colors in the 3-dimensional space, you can map them. You pretend that this is like a dot cloud of 3-dimensional points, you know, with your Y, Z, and X, right? And here's the color that you want, and you have all these other colors around, and use the distance formula to determine which is the closest to what you want. But the problem with that is, while technically that does get you the closest in terms of RGB, that doesn't actually correlate well to what we see. So like if we said this is RGB like this, then you could do the same thing. But so to that point, apparently, from what I'm reading, YUV space, points that are closer together are actually more similar in color. We'll see. We're going to test it out. We're going to start off with this, which is a picture of my dog Charlie. And I like it because it's got sort of a few different colors, not too many. It's got black and gray and white, and then it's got the blue for his collar. Makes it easy to kind of see if we've gotten it close. So what we're going to do initially is we're going to, and we'll probably want to just make this, I'm almost thinking we just want to make this we'll output some text that we can put into the compiler, or sorry, into the code here, and just compile it in hard-coded. The only reason we might not want to do that is if we change what these values are for the palette, then we've got to recalculate that. We can, you know what, it's only 64. Let's calculate the YUV at startup. Excuse me. And then we can, if we settle on a palette, we can keep that hard-coded and stop calculating it every time. So we've got our vector 3 there, and if we look, Wikipedia has an article about all of this, and one of the things that they provide is a handy diagram that shows how you can convert from RGB to YUV. The simple, nice thing about this is this matrix formula for doing it. If you've never done any sort of linear algebra or matrix math, it can look a little daunting, but basically all we're saying is, where did I close mischief? I must have closed mischief. I've been having that problem a lot this week, that I closed programs that I'm still intending on using just out of habit of closing them down so they're not running in the background. So if we take this as an example, can I just copy the... that didn't work. Let's do this. So we have a matrix. It's a 3 by 3 matrix, right? I'm not going to do the whole thing, but we have 0.299 and 0.587 and 0. What happened? Oh, it changed the color. You're not behaving tonight. 0.144, and then you have your vector of R, G, and B. And what this turns into is a series of equations where you get your y prime is equal to R times 0.299 plus G times 0.587 times, and then B times the 0.144, and subsequently you do the same thing. So then U is equal to R times this value, and G times that value, and B times that value, and V is equal to RGB times these values summed. And that gives you your YUV value, which we then will use to determine what colors are similar. Now, that all sounds complicated, potentially. Again, if you've never done matrix math, it's really not. It's just a simple notation of how to do. It's a simple way of kind of taking these discrete steps and turning them into a very simple representation, or an elegant representation of how to do the same thing. And then from there we can use the standard distance formula, which if you've done any sort of geometry, it's the difference of x2 minus x1 squared plus the y2 minus y1 squared, and then you square root, except in this case we're also doing with z2. Oh, I messed up my writing there. It looked like I was squaring it. 2, 1, 2, 1, that's y, and z2 minus z1 squared. Right, so that's a three-dimensional distance, and then we want the absolute of that. And then the RGB value, or the YUV value that has the smallest distance, is the one that's closest, and that will be the one we select. So we need to know not only what the color is, but the index, so we can call back the RGB without reconverting it back from YUV. Let's start with doing the conversion to YUV for the NES palette. All right, so it's just called the NES palette. Excuse me. So vector, oh no, so temp x equals NES palette. It's in GUI. Wait, is this a pointer already? No. Come on. And that should be a t-pixel. And we can just do this. R, G, G, stop it. Okay, so that gives us that value, and then we're going to do the conversion here. So we'll just do it right into here. We'll say YUV entry Rx equals temp x. Actually, we don't even necessarily need. We don't need that. R times 0.299. Is this in a case where we are scaling from 0 to 1 for the RGB value? Yes. So, okay. So, we do have to... Alright. I take it back. We do want temp. And I want to change... I'm going to change this vector to float. Stop. Okay, so vector 3f, and that's a vector 3f, and that is vector 3f, and then so all we're doing here is we're converting the value from a range of 0 to 255 to 0 to 1, right? It's just a simple operation where we're dividing by 255 and storing it in a floating point, because these operations for converting to YUV are in the color space from 0 to 1, not 0 to 255, like the RGB values that are used by Tiger. So, all right. So this is x times 0.299, right? Oh, 2126. Float plus temp.y times 0.7152 plus temp.z plus times 0.0722, and we're just doing the same thing over and over again, except we are now changing these values. So this is minus except I knew it was 2.299. 587 and 144. 114. All right, and then this is minus 14713, 14713F. And this is 0.28886 minus 0.28886. There are 3 eighths. And then this times 436. And then finally 6 and 5. And
0.51499 and minus 0.10001. These are all floats. All right. So in theory, that should give us our YUV value for the entire palette of the NES. So let's see, GUI, NES palette, YUV. Not helping here. Gee, look, it worked when I added it that way, but oh, I just can't spell? Is that what you're saying? And the error message is wrong? Now, wait a minute. I just can't spell. That doesn't help. All right. Okay. And so we're getting values. I don't know if they're right. I assume that they're reasonable. One sort of dumb thing that I did, I guess I should make this a function. RGB to YUV, and it can take a RGB and a YUV out. RGB to YUV. And we'll obviously need the equivalent reverse function, 3F YUV. And this will just be vector 3F temp, which we still want because we need to convert. And then this should be this, and this should be that. Okay, and then let's flip that back around. YUV to RGB, and that just does the opposite thing, right? So we've got a T-pixel as our temp. Well, so actually not quite. So we want to work with the vector 3. What we want to do is we want to reverse the process in float, and then we will convert back to our unsigned byte. So this is the process to convert back if you have a YUV. So you're going to multiply by, let's see, so this is going to be so that's taking those, and then, yeah, so these values. So 1 0 and 1.1, 1.1, 3983, and this is going to be RGB. Oops. Well, no, this is going to be temp. Sorry. This is going to be temp XYZ because this is the intermediate floating point form in a range of 0 to 1. And then we're going to do this. We're going to say this is equal to temp x times 255. Oops. So RG, stop. Right, so we're just converting back to a range of 0 to 255, and these are unsigned chars, so unsigned char, cast it, just so it doesn't complain that we're losing precision because we don't care, or at least we know. I don't know if we don't care or not, but we'll say for now we don't. We know that it's going to happen. All right, so now let's see. It's 1 across the board on the first value here. It looks like. Then this one is minus 0.39465, and then Z is 58060, 58060, and this is minus. And then this is 0, and this is 2.03211. All right, so that's our conversion back. So RGB2. All right, so we don't need this anymore. Let's make sure that that works. And we're getting values. That looks like that's working. All right, so now that we have that converted, do we have, I guess we don't have any functions in here. What is this in? This is in helpers.h. Is there helpers.c? I don't remember. There is helpers.cpp. Okay, so what we can do is we can say float distance vector 3f a vector 3f b. That returns a magnitude, right? So that's the definition of the function in the header, and then we can implement it here. And this is return ax minus bx. These are pointers. I'm just debating if I want to do a call to, you know, we could do the call to the power function, but I mean we're just squaring it, so it's really not that big a deal. Just a little more typing. Plus that, and then this is y. Oh wait, yeah. And this is z, and we don't care about the actual distance, so we don't really even have to do the square root. I mean, if we cared, If we actually cared about what the precise distance was, we'd do the square root to get the distance. But because we don't care what the square root is, and we just want to know which one is further, we're not going to bother. So actually we'll call this distance squared. Hopefully this won't cause a problem. It shouldn't, in theory. Did I not name that properly? Yeah, okay. Alright, so now let's go back to where we were at when we started, where we were going to convert the image to index, to indexed, right? So that's our span of colors. And let's do this. So for int I is less than span, for each of these we're going to convert to a vector 3f yuv equal and then RGB to yuv, right? And that's going to be our image pixel we're going to give it our yuv, not yuv, and then that, and I just thought of something and I don't want to lose it. What was it that I was thinking of? Oh, we need to size of what did I say this is? Unsigned char times span. And we'll cast this to unsigned char and memset image indexed 0 size of unsigned char times span. All right, so we've allocated our memory. We've allocated our memory, we've zeroed it out. Now we're going to be able to give it an indexed value. And so that's going to convert to YUV, and then what we need to do is we need to loop through the NES color palette and list 64, J, and just look for a color that matches as close as possible. Let's say match index is currently -1, and distance is equal to, we'll make it some extremely large value. That should be a float. And so basically what we're going to do is we're going to take the distance squared of this color versus the NES palette YUV, and then if it's smaller than distance, we will set the new index, the match index, and then that's our color when we come out of the loop, whatever the resulting value is. We could probably make this a little bit faster by doing some sort of lookup. If we see the color beforehand, we want to standardize on the color, or not so much standardize. The algorithm should be, that we're writing here, should be deterministic, so that means it should yield the same indexes every time we iterate through, but that said, doing the calculation for the same RGB every time is probably not necessary, although depending on the image that we're processing, like in the case of this one, there's a lot of noise here, so it's going to yield a lot of different colors potentially. So let's let's just do it this way, and then if we need to optimize it, we can do that later. So let's get distance squared of our colors YUV and the NES palette. It's in the GUI namespace. NES palette YUV J. This should be distance squared. Why are you not? Oh. I made this take pointers, I guess, so I could use it for pointers, but it doesn't really matter. Alright, so we get the address there, and that's good. We don't want to copy those into the call, I guess. If D is less than distance, then match index is equal to J, and distance is equal to D, and we keep going. Because we're not finding the first one that is a closer match. Obviously, we are finding the closest match. Alright, so then what we want to do is we want to say image indexed I is equal to match index. We probably want to look at this and see what that looks like, although I don't know that that's particularly useful. What we can do is we can convert it to a meta tile and then open the meta tile in the viewer that we were just working on in the last stream. Alright, so let's make sure that we get into here, and then well, that's going to be a problem for us here because it's not 32 by 32. Do we have a sprite convert already? We didn't implement that. Oh, okay. Well, here's what we can do. Let's we really can't make it 32 by 32 because it's going to be, well, I guess we could. I mean, we'll see something, right? Let's save this as charliemt.png. All right. So all right. The argument is -png to mt. -png to mt, and then it's users Michael desktop charliemt.png. All right, so let's make sure that we're getting there. We are, and then we're getting into, we don't care about that. We're getting into the convert. Let's see what our distance looks like. All right, so I mean, it's at least seems to be doing what it's supposed to. Let's see what this yields. I'm curious. And then Let me see, where does that... All right, so put it right there. Users, Michael, desktop, Charlie, mt.metatile. That should load that in the viewer now. Okay. Not exactly. Now, to be fair, some of this is because we are using way more than 4 colors. If we were to go to this and do it indexed and look at the let's look at what this looks like. And you can still see some of the outline. I wonder what that looks like converted before we sort of blast it down into only 4 colors. Let's open up a window and show that. PNG to metatile, Michael, desktop. So at least we get a sense of, did we accomplish the first goal of getting the image converted over to indexed colors successfully? So, or the NES colors successfully first. So users, Michael, desktop, Charlie, mt.png. Although we can use the regular one here because there's sort of no restriction on what we want to show, right? So let's do that. So let's Tiger window. Let's go big. Let's make it 800 by 800. We'll just call it result. And what does that return? A tiger. Win. And then what does the loop look for? I don't remember. Tiger closed. While not tiger closed, while not tiger closed, when okay, so it should have the window, and then it will let's draw current image. No, draw onto the window current image. Just do it in like 2020 00 current image width, current image height. Actually, you know what we can just do? I know this is 256 by 200. So let's do that and make it 00. All right, so that's got that, and then one thing that we're not doing, stop it. One thing we're not doing is we are not replacing the RGB value with the equivalent palette value from the NES. So let's do that. Pix I is equal to GUI NES palette match index. So that will change the RGB value in the image for when we draw it to the value from the palette. So let's see what we get here. guess I need to... Do we need to show it? I don't remember how that works. That was ages ago. Tiger. It's initialized GUI. Tiger window, screen. Do I have to show it? Well, not it, not Tiger closed. I'm doing it here. Oh, Tiger Auto. Where's my window? Oh, that was not what I wanted to do at all. Too small or something? What's going on? Why am I blanking out on this here? Is it in this that I need to do something? No, that's the window. That's all the GUI stuff. That has nothing to do with the Tiger stuff. Not Tiger closed. Seems to work just oh, Tiger update, that's why. So, yeah. All right, so that's definitely Charlie. I guess now the question becomes, is that a reasonable representation? Let's see what Photoshop does. If I reopen this, so Photoshop will take, I have a palette definition of for the NES. If I say I want to make that indexed, and I want to use a custom palette, I can say OK, and that dithered it quite a bit. Let's do it without dithering. None. Okay, that's actually pretty close to what Photoshop did. I mean, you can see, looks like the colors are slightly different. I think that's probably a difference in the palette itself, not so much in the algorithm, because overall it looks pretty much the same. I mean, there are certain color choices that are sort of odd, but I guess that's sort of the best that it can do given given the color choices that are available. I mean, you can see it's adding this sort of teal color where we have some teal and green mixed in. I mean, and to be fair, like I said before, this isn't really necessarily the best image to use, just because it's got a lot of noise from the window that was in front of him. Do I have... We could try a red-blue gradient. Just say oh, damn it. Stop doing that. Just show me what I opened, please. Alright, so create the gradient, and let's sort of, with blatant disregard for the NES, just choose actually, you know, let's choose, I'm tired of that red-blue gradient. Let's use teal and purple. Let's make it really kind of interesting. So we'll save that out. Export as PNG. We'll call that new gradient.png. Okay, so that's new gradient. Let's see what that looks like. Did not find the file. Where did I export that to? I thought I... Oh, not to my desktop, that's for sure. All right. Let's try that again. All right, so that gives us sort of that weird banding. I imagine we're going to see a similar... Yeah, we see a similar thing, although I have to say that Photoshop is doing a better job with the transition than we're doing here. I imagine they're using a more sophisticated conversion than we are. But that said, this isn't terrible. You know, seeing similar coloration, and we should have gotten a meta tile out of that. New gradient PNG, new gradient meta tile. Let's see what it saved. Seems like every time I accidentally gonna bring the desktop forward, the stream loses a couple of frames, which is annoying. I also upgraded my graphics card and my CPU in hopes that that would help the stream stuff. So we've got 8 cores now. It seems like OBS isn't using that much of the CPU. Is there a way to see what is using the graphics card? I don't know. They add something to this. Oh yeah, look at that. That's cool. So OBS is using about 20% of the GPU. All right. Well, I can only imagine what it was when I was using my other card, which was old and awful, so hopefully this is better. In terms of the stream quality and the recording. We'll find out. Anyway, so let's go take a look at this. Alright, so our colors here are good, but it obviously didn't translate so well in terms of well, that's interesting. So why? I guess the indexed colors are not coming in from the meta tile in a 0 through 3. Let's see. And the palette is actually the palette, but stop it. Palette is the palette that we converted over to, but we are not, the index colors are not being kind of scaled down to 0 through 3, which, I mean, that makes sense. I didn't think we were doing that, but I didn't necessarily remember either. So that's probably why the palette looks pretty reasonable, but the colors that are in the image itself are not. Yeah, so let's go to where it loads the meta tile. Open file, it just reads it straight up and out of the file. So when we went to save it, what is this? Why is this just floating here like stupid? What the hell, Visual Studio? Is that the diagnostics window? Okay. Yeah, so this hasn't been changed at all. So we need to further process these colors in order to get a value that is from 0 to 3. And rather than me sit and read about how to do that effectively, we can come back to that in the next stream. One thing I can do is when I do the export, oh, I can't through this because it doesn't have the control for that. So I can say, so this does 4 color. This doesn't let you limit the number of colors. And this is going to be a indexed PNG, I believe. Let's save that and look at what that actually is. Gradient PNG. place. Okay, so if we go back and look to what this actually looks like when we load it in Tiger. I want to see what the C type here is, which will tell us what kind of image it is. So C type is 3, so it is paletted. It's already paletted, which means that we wouldn't need to do the conversion that we're doing. How come that window didn't pop up? Oh, because we're not doing the conversion. I mean, eventually we wouldn't want it anyway, so it was just more of a thing to be able to see what we're getting. Once this is part of the tool chain, we don't want to we don't want that pop-up to occur at all. Okay, so I mean, I'm reasonably happy with the YUV conversion right now, because that is giving us values that are in the range of the NES palette now, and it looks almost as good as what Photoshop is doing, which I'm pleasantly surprised by. I wasn't exactly sure what it was going to give us, so that's pretty good. I'm happy with that. So let's see, where do we go from here? So if we load this up, this is going to look wrong. And it looks wrong because the palette is wrong, and well, you know, so we could fix that. That would be good, because right now what's happening is we're getting the RGB palette out of the indexed PNG, but we are then, as a result, getting values that are different than what the NES can actually represent, and we're using these values, these index values of 0 to 3, and the palette is kind of off. So let's fix this. Let's approach this with the idea that we're going to at least get the palette on the indexed images to work properly, because that's an easier problem to solve right now on stream without me doing a bunch of reading that's going to be boring to watch. So what we can do is we can still make this call to convert image to indexed, but we can say if image indexed, then we need to free image indexed, and image indexed is equal to null. I'm setting it to null even though we're allocating it again here, but it's just, I don't know, just force of habit. Yell at me if you want, that's fine. Okay, so then convert image to indexed. Basically, we're going to do this all the time, and if it's not indexed, then we will convert it properly to the indexed color scheme. If it is indexed, then what we'll see is that it should take the colors and map them down into the NES color palette with the proper number of colors. So PNG to MT. And then okay, that's cool. I mean, that's what it's supposed to look like. Now all we need to do is swap the fact that that was in the wrong spot, and now we've got a meta tile that's got the right colors. And I mean, we could even that's not bad. That's less problematic than it had been. Although, why are we missing a band of colors? 1, 2, 3. I guess it's because we're really saying there are 3 colors plus black. Or 3 colors plus the background. Right, so if we save that, and then we should get the exact same thing. So we'll go back to export this PNG to meta tile. That didn't look like that changed to me. Yeah, it did. Okay, that is better. That actually looks like what we were seeing in the save here. So now, if we have an image that is, oh, okay, I see. So there was also, because it was so small, it was kind of having a hard time showing it properly. Yeah, so that's right, and that's got the colors from the palette properly mapped to the NES color palette now, and that is kind of neat. So actually, so then we should, in theory, be able to, let's do this. Let's take Charlie Boy again, and we'll do save as, we'll do an export on him. And we'll do it in 3 color. Do I want to do dither? I guess I do, given the low quality. So let's say Charlie MTPNG. And then let's try and bring that in. That should actually look much better than our previous attempt. Okay, the color that it chose, I'm surprised it chose that brown. You know what? I was surprised, but it actually seems like to me that that's not that far off from the color that it used in Photoshop. Which was, you know, just an arbitrary sort of three colors. It wasn't even mapped to the NES. If I do that, and I load cancel mode RGB, back to indexed, previous, yeah, it's back to the, it's showing brown also. So that's kind of cool. That actually works. So I like how bright his little bone tag is. But that is not going to export because it's too big. So now what we can do is let's change this to be 32 by 32. Oh man, that's way too... Alright, it's not going to be able to do it because the resolution is too low and the colors are sort of impeding choices here. So then we have that, and then let's save that as... oh no, we got to export that as... that... Save... Replace. Okay, so we'll convert that over again, and this time we'll get a meta tile out of it, and you can see his sweet little face there. And let's yeah, that's not actually that bad. Not sure. So that's the background. I feel like I'd probably change that to be more like his actual coloring, but vaguely resembles the original image. But I'm actually pretty happy with the conversion from the larger one, even though we can't turn that into a meta tile because it's too big, compared to what we allow for meta tiles. Alright, so that's an option 2 now. So now if we have something that's in a program where you can export PNGs, index PNGs with 3 colors, we can now convert that into something that uses an NES palette, and gets a pretty reasonable result. So that's cool. That wasn't too hard. Alright, so let's... I think the last thing I want to work on for tonight, because my voice is starting to go, is getting a sprite created from a PNG. So tool action is equal to convert PNG to sprite. Wow, okay. Current image is equal to, we're just doing the same thing, right? We're loading our image from target file name, and then we're going to convert it to an indexed image. You know, we can even, I wonder if we can share. All of this stuff kind of becomes metatile specific. And the window is really just a stopgap. Like, we can even take this out from here and just move it up because I just want to see what happens. So we're not going to check the size, even though technically we should probably put some sort of limit on the size of sprites in the system, but don't really care about it right now. All right, so at this point we just want to make a sprite. So what do we need to do that? All right, so load image palette. Same deal with this. Current sprite. We're going to copy current palette over size of, what is it? What is the palette size? Right, and then for the sprite, the image is same thing, it's just the indexed value, but I believe oh, you know, we can call this guy, this will help us. Instead of reinventing the wheel here. So let's do that. Okay, fine. Don't. Oh, okay. So, so this is doing it with just a file name. So what I guess I really want to do is I want to say target file name oh no, okay, you pass the, that's what I thought. I was confused. Current image, and then our palette. So we don't need to do that. The only thing we need to do here is we need to replace file extension for target file name with, what is this max file folder? Yeah, with .metatile. Oh, not metatile, the sprite. Did I? Okay, so I didn't do that for metatiles. Interesting. All right, not sure why, but I'm sure there was a reason. Okay, so that's it. We call create sprite. It handles the basic creation of the sprite for us. It doesn't really know anything about what we want to do or if it's animated or anything like that, but it will take an arbitrary PNG and turn it into a sprite. So now we can go back to this and we can save this out as what we had before as a 3-color. Obviously this is huge for a sprite. We wouldn't do this. Just replace the MT one. And I'm going to just kind of run this through the debugger. Okay, so that's good. We're going to get our palette. We're going to replace the file extension. We're going to write our sprite, and we're done. So we should have Charlie mt.sprite. And we do. All right, so now we want our view mode so that we can work with sprites the same way we made it so that we could work with metatiles. So else if what did I call that? Tool action equals view sprite. And then basically I want the code that is here. Right, so we want to draw our palette view, we want to draw our sprite. Is there any other stuff related to sprites? Sprite selected. Yep, so this part related to if it's an animated sprite or not. And then the drawing is actually the same for this as it is for the meta tile. Let's do this. Let's move this out because it is essentially the same. We can put that, keep that there for those buttons that are specific to the meta tile. And then sprite selected is equal to true, and then meta tile selected is equal to true here, and it's not going to change. Alright, so our draw code, we're left offset, right offset. Put these here, and then these as well. So this code is essentially going to be the same. I just need to add this back in for the sprite related drawing. Right, so if sprite is selected, then we're going to draw this stuff. Otherwise, meta tile selected, then we'll do that. Oh, okay. If sprite select, so this is actually separate logic. Sprite selected and viewing collisions. Yeah. So that's the same. Sprite selected there. Palette view, that's already in. We have this. That's already in there. Color selector. Oh, this is not going to be there, so let's add this in. And that should be everything for the sprite drawing. Let's see how badly this is messed up here. Image selection. What was that used for? I don't even... Oh, selection was if you clicked on something. Where you actually clicked. Alright, so that's that. Let's see. So that converted it to a sprite. Oh, okay, yeah, I need to go to the view mode. Let's see what that ends up looking like. Exception thrown. Current image is null. Okay, well, that's entirely possible. I don't know if we're actually loading the sprite correctly. If it's sprite, oh yeah, we're definitely not. Load sprite. Current sprite, and the sprite file name is target file name. Free image, current image, current image. Do we have sprite to image? We do. Okay. Current image is equal to sprite to image. Giant ass bug crawling down the side of my desk. Sprite to image, and we have our current sprite. Sprite selected equals true. Right. It's mostly correct. We've got, well, let's take a look at what happens if I use a meta tile. Did I break drawing? Okay, so that's actually okay. So it's just sprite drawing that's not right. Hey NES Homebrew, what are you having problems with? Let me take a look at the preview here. It looks like Twitch might be having some sort of issues with streaming. Or is it just me? Let's see. Looks like it just might be me. That would be weird. Although I did change some of my encoding stuff. I also can't see a damn thing with the way I've changed the screen resolution stuff. Hold on a second. Let me change this to be something actually readable on the top display. Oh, except that now OBS is way confused. And I can't. Yeah, so Twitch is showing my stream health is excellent, but meanwhile, if I try to look at the preview for this, it is not happy. Weird. And I can't. Oh, I'm going to stop the stream for a moment and restart it. I'm going to stop streaming for a second here. I'll even stop the recording. I'll just have to merge them. It's excellent, but meanwhile nobody could actually see anything. So bizarre. All right. So right now, it's not drawing. It's not drawing the sprite properly. So let's look at why that is. Current sprite, let's see. 256 by 240, number of bounding boxes is 1, frame width, frame height. Why is frame width 0? Is frame width the byte? I guess it could be. Let's change Charlie Boy so that he is only 255. Save, and then let's re-export this pup. Save for web. Save. All right, so now let's do the re-export of this sprite. That looks good. All right. And then if we reopen this, okay. So, I mean, the size is because, I mean, it's a huge image. The palette is okay. We're not getting the color picker. And I imagine that is probably because that was a shared, the color selector was shared. So let's bring that back up there. Okay. And then the palette view, that is also probably... How was I doing that? Okay, so that was just this. I think the only difference was that I... Excuse me. Image. This is okay. So it's just the positioning, I think, that's wrong. We can just steal this and take this from current sprite. That should look better. All right, that's better. the bounding box offset is wrong because we had changed how we were handling the left offset and the right offset. It was, I think, hard-coded. Not the right offset, the top offset. They were hard-coded for some of these things, and so I need to change that. All right. Now the only thing that's not drawing is the sprite. Why? Why are we not seeing a puppy? I imagine well, let's take a look at what's actually in the sprite here and see if there's anything all zero. Okay, well, there is your problem. Question is why. You call create sprite. Well, I gotta go back to actually creating the sprite to find out why. Okay. So the height is 240, the width is 255. The definition of the sprite, we have short, width, and height. That's fine. Those are 2 bytes. Is it just the image data is non-existent? What's going on? There's our image. There's our indexed image. Is the indexed image not set? No. Okay. Why is that? Convert image to indexed. If it's set, then free it. We should be getting into this because it was indexed, so now we're going to free it, and then we're going to allocate new, and then we're going to convert from YUV to, or RGB to YUV, and do the nearest match. When we step out of this, the indexed value, and that's that. That has yeah, I mean those are pretty reasonable values. In that they're not all zero, so let's see here. If we see the pup, we close the window, it's still not all zero. Oh, load image palette is, what is that doing? Current palette destination image. Eliminate any use of XD. Oh, it is. It's remapping. Okay, it's remapping the image, but it shouldn't. That should be okay. We should still be seeing non-zero values. It does look like we are. So that's normalizing it from 0 to 3, which is fine. And then stop it. Oh, okay. No, that's what we wanted to see. Okay, are we seeing all 0 now? We are. Why? It's like, oh, I'm in this part of the wrong part of the call stack. Well, so excuse me. Definitely starting to run out of voice here. I'm confused. Those are the colors. This is the indexed value. But we're getting nothing but 0. Whereas up until that point, it seemed like it was okay. That's bizarre. Current image indexed. Let me close these files here. So we shouldn't be getting things going away. We should be getting... Let's find a spot where we have values other than 8, because those are going to consolidate. Excuse me. Those are going to consolidate down to the same value when we normalize the palette. Here. Okay, so once we run this, that's okay. Image indexed. I mean that looks all looks okay. I mean it's got did I just jump the gun here and it's fine? Maybe it has nothing to do with that. All right. Is it the, let's see. Oh, maybe it's not initializing the draw properly. Let's see. So for this, image changed false. Tile selected. that's the color selector. I mean, I don't know why that would matter, but just to make it consistent. Alright, so now what? So GUI, is it this ID is already in use? No. Meta tile selected or sprite selected. That's all if it's clicked. Image changed, draw grid selection, current image, image height, image width. Oh, maybe the image height and width aren't being set. Yeah, the image. Okay, that's not being set. All right, so in the meta tile, it's defaulting to the image width and height, and then, okay. For sprites, that's not always the case, because if it's an animated sprite, we consolidate the width down to match the frame size, but that's okay. So image width equals current image. Let's just default it to the width and height of the image, and that should fix it. Okay. Now the only problem is that it's a huge picture and we're scaling by 16, so let's just double it for now. Yeah, there we go. Alright, so obviously this isn't ideal in the sense that we would never have a sprite this big, but the point was just to see if we could get it to load and draw properly, and we can switch there. So now the background color is the gray, and the lighter gray and the blue and the brown are not the background color. And we can even save that, so then when we come back to it, we could save it if that was working. Save sprite. If sprite selected. Oh yeah, that's not going to work. Current sprite, target, file name. That's what happens when you rip apart all your previous code. So if we reopen that. Yeah, there we go. That saved that. We can even swap around the orders if we wanted to, but no, it's more or less Charlie. Alright, so I'm going to put the scaling back to 16. It might be nice to make that changeable so that it's not fixed at 16, but for now, I'm not going to mess with that, at least for tonight. Alright, so now we've got our color conversion from RGB to NES palette. We've got it working well for, well, I mean, the general case works. If you get an RGB image, it will convert it down to, it'll convert it down to the NES palette. It works better with indexed images because it's reduced down to only 3 colors it has to do it on, but we have to fix that. I gotta research how to actually do that. And we got our sprites saving. We can work on getting the animated stuff to work properly. Right now it's hard coding the size. We can get rid of the window that pops up. Where is that? That was just purely to see what the result of the conversion was, but I'm reasonably happy with that right now. Actually, I'll comment it out so that we can bring that back if... Oh, come on, man. We can bring that back when we get the color reduction implemented. So I think that's it for tonight. My voice is kind of getting on the tail end here, but as always, thank you for watching. I will post the recording of this onto YouTube tonight after I consolidate the two videos, the two recordings down into one, since I had to restart the stream in the middle. If you'd like to find me, you can find me on Twitter at Clairvis. You can see when I post recordings and who else will be on the stream. As I mentioned, Wednesday, I'll be having someone on the stream to chat about homebrew. I'm very excited. Very excited to have him on and have him talk to us about his games. Been looking forward to this one, and just kind of had to work around all the travel I've been doing and his schedule as well. So that'll be this Wednesday. If you have any questions, feel free to comment on the video on YouTube or hit me up on Twitter or Nintendo Age, and you can find a bunch of smart people who have worked on NES programming for longer than me, and the forums at Nintendo Age and NESDev. But yeah, as always, thank you for watching, and see you next time. See you Wednesday. Keep an eye out for who we're going to have on stream on Wednesday, and see you then. All right, have a good night.